All right, let's gather some information about this parabola that happens to be in standard form and determine whether it opens up or down, find its vertex, find its axis of symmetry, and get a nice graph of it. So the very first thing I'll note here is I've listed standard form over on the right-hand side. Sometimes this is referred to as vertex form. All right, why we call it vertex form is because it kind of helps us find the vertex pretty easily. But the first thing I want to identify is whatever A is. So as you can see, A is going to be a number hanging out in front here. And you'll notice that we, in this one, have a negative out in front. So in our case, A is going to equal -1. Because A is negative, this is going to open down. Now if A happened to be positive, this would open up. So opening down means it's going to have this kind of look going for it. And the end behavior is going to go towards negative infinity in both directions. All right, next up, let's go ahead and identify what is H and what is K. As you can see, H is going to be on the inside of this set of parentheses with the X, but the sign is flipped. So as we take a look at ours, what we want to do is we want to identify our H is going to be 3, except in our case, it has to be -3. So if we did x minus a -3 on the inside, that's going to be equivalent to the x plus 3 that's in ours. All right, next up, let's go ahead and identify our k. The k value is what's added or subtracted from the end. As you can see on ours, it's going to be a +4. So our vertex, as we're thinking about graphing this, is going to be -3, +4. So we're going to get a highest point right here on our graph. The axis of symmetry is pretty easy to identify as long as you know where to look. It's going to be this vertical line that cuts right through our graph, right through the parabola, and cuts it in half. All right, so it's a vertical line, so it's going to be all the same x values on this vertical line, and those are going to correspond with the x value of the vertex that it has to go through. So x equals -3. So right now, we only have 1 point on our graph. We know it opens down, but it would be nice to have at least one more point on our graph. To find one, what I like to do is find the y-intercept. All right, you could go for x-intercepts, but the y-intercept I find is fairly easy to find usually. So that always occurs whenever x equals 0. So let's go ahead and evaluate this with x equals 0. So we get y equals the negative of 0 plus 3 quantity squared plus 4, replacing the x with a 0. So really that's the negative of 3 squared plus 4, which is going to work out to be the negative of 9. Remember, we're going to do the exponent before our multiplication, plus 4, which works out to be -5. So we have a y-intercept as 0, -5. That point right there. Now, if we want to find one additional point, what we could do is we could say, well, that is 3 units away from our vertical asymptote. Sorry, not vertical asymptote, our axis of symmetry. So over on the left-hand side, I can count 3 more units over there and get 1 additional point. Now, our y-intercept happened to be on the graph paper. If you did yours and it doesn't work out to be on the graph paper, what you could do is you could evaluate at any additional value for x. So because our vertex has an x value of -3, what you may want to do is evaluate at -2, a value pretty close there to the vertex is x value. Now I didn't calculate the x-intercept, so I'm going to go ahead and just draw this in here. And if you're using an online platform to do this, what you usually end up doing is just down below clicking on the graph that looks like a parabola, and then clicking on 1 point for the vertex and 1 additional point, and it'll draw it in there for you. All right, so I hope this helps out as you're working on parabolas, quadratic functions that happen to be of the standard form.